Today we are going to study geometry, 3D geometry problems about objects in three-dimensional space. Right. Well, so before we study 3D geometry, right? What do we already learn? We learned the area of the square and the area of rectangles. Okay, so let's have a quick review. We needed to know, right? So we give up, this is a rectangle, right? Then for the rectangle, we have, the area formula, right? Area formula is going to be just x times y, that's it. And then also we learn the circle, right? What's the radius r? For the circle, well, for the perimeter of this will be 2x plus y. Right? And then for the circle, the circumference is a 2 pi r is the radius, and the area is going to be pi r squared. Right. And of course we can study triangles, right? Triangles, the area formula for the triangle. Triangle just half of the rectangle, right? So triangle, right? And we know the formula for the area of triangle, right? So this is area is going to be half of the b times h. Right? And we also have other formulas for the triangle, but we don't need it to know right now. Another important property is about the Pythagorean theory. Okay, so this is a b, this is a, this is c. It's a right triangle. C squared equals a squared plus b squared. Okay, and this is also used in geometry very often. Okay, so those are the list of the formulas we probably have to use it very often. And now we are going to study 3D objects. Okay, the most simplest one is called rectangular box, also called a prism. Okay, so it's drawn like this. Okay, 3D geometry, you have to draw it. Right. So see, it looks like a 3D right now, right? Object, it's a box, right? A and the B and the C. Okay, so the height is C, the length is B, the width is length is A, the width is B. Okay. This is called prism. Okay, in general we call it rectangular box. All right, let's find out the surface area. Okay, let's find out the surface area. Surface area, how many faces here? You can count 1, 2, 3, 4, 5, 6. I think the total 6. Okay, but because this is a rectangular box, so there are 3 pairs of identical rectangular faces. Okay, so the surface area is going to be the area of the front side, right? Front face, which is AC, and also the one behind, right? It's also it's identical, so it's twice of AC. Then the area of the two sides is the length is B, the width is C, so it's 2BC. How about the one on the top? The one on the top, here's A, here's a B, right? So that's why it's 2AB, because one on the bottom is also. So that is the total surface area. Okay. Now we have to introduce a new concept. It's called the volume. In 3-dimensional space and object, a solid. Okay, and you can talk about volume. Okay, the definition of volume is just a product of the 3 sides, A times B times C. Okay, this is a volume formula, and it indeed tells you how many unit cubes there. For example, yeah, a cube, the special case is a cube, okay? Yeah, the cube. The cube is all the sides are equal. Okay, it's A and A and A, all the sides are equal. It's called a cube. A unit cube means when A equals 1, okay? Okay, unit cube is all the sides are equal to 1. Okay. This is 1 unit cube. Now, let's understand the geometric meaning of the volume, okay? So consider the following box. 1, 2, 3. Okay, 1, 2, 3. Okay. So this side is 3, this side is 2, this side is 3. Okay. So the volume is going to be 3 times 2 times 3. So it's going to be 18. So 18 is actually the number of the unit cubes in this rectangular box. This actually is the number of unit cubes, okay, in the prism, okay? And you can count that. How do you count? So 3 times 2 is just the number of cubes in the base, right? 3 times 2. Then you have 3 layers, so times 3. Then you get total number of the cubes. Okay, so the geometric meaning of the volume is basically just tells you the number of the unit cubes. Okay. Now let's find out what is the surface area. Of this. What is surface area? Well, you just need to look at how many faces. That's a total 6 faces, but there are always 3 different pairs of identical faces. Right? So the surface area is going to be, this side is 3, right? 3 times 3. Okay, and then it's identical. You have another one behind that is identical, so it's 2 times. So every term you multiply by 2. Okay, so now you have the side on the right hand side. That's 2 times 3, right? And on the top is here's 3. That's 2. So 3 times 2. And there's another one on the bottom. So total 6. So I have to multiply 2. Okay. So that is the surface area of this of the box. So let's add them together. It's 9. 6 times 2. Okay. And yeah, 21 times 2. It's 42. 42 just tells you the number of the unit squares on the surface. This is actually the geometry meaning. This is a number of unit square on the surface. Okay, and you can count all of them, add them together. Indeed, it's a 42. All right, so now let's take a look at the next problem. A box with an open top has a square base with edge length of 2 and height of 3. Okay, so we have a box. Okay, the top is open, with open top, has a square base was edge length of 2, okay, and height of 3 units. Okay, so you draw the square base, right? Okay. Okay, the base is a square. The height of 3 has 2 has 2. We want to find out the volume and the surface area. Right, let's try this, okay? Yeah. Yeah. The volume tells you how many unit cubes does this box hold, okay? And the surface area is how many unit squares over the surface of this box. But this box, be careful, this box has an open top. So that means, yeah, this is our box, right? So the top is not included. Okay, so be careful when you calculate the surface area. But for the volume, it doesn't matter whether you have a top or not, right? So the volume is a product of those 3 numbers. So it's going to be 12. So that means this box holds 12 unit cubes. Okay, if you like a cube of sugar, right? You know, for the coffee, right? Remember, right? How many unit cubes you can put in this box, and then you can put 12. Okay, you can put 4 on the base, and then you can have a total 3 layers. So 4 times 3 will be 12. So there should be, it holds 12 unit cubes. Now, to count the surface area, the surface area, be careful. Yeah, you have to look at, right? The front, okay, the front and the back, so twice, double it, right? And the side, you have 2 sides, so it's going to be 2 times 3. Okay, give you the area of the face on the side, but you have 2 left side, the right hand side, you have 2 sides there. That's why I multiply 2. But you only have the bottom part, you don't have the top part, so it's 2 times 2. Right, that gives you the total surface area, so it's going to be 12, and that's 12, and here's 4. Okay, so the total is 28. Right, 28. Yeah, the surface area is 28. All right, now you have to use the imagination. Let's do the following problem. I have a piece of paper, okay? This piece of paper typically is 8 inches. Here's 11 inches, okay? What I'm gonna do is I'm going to cut 4 corners, right? They're gonna be cut, okay? So each is 2 by 2. So what is remaining after you cut it? This is the remaining part. Right? This is the remaining part. What I'm going to do, I'm going to bend it to make a box. So what I got here is I got a box, right? So let me color it. It's the same. Yeah. So this is a box we made, right, from this paper box. Okay. My question is, what is the volume of the box? Of the box you make. Okay. That means how many unit cubes you can put there. Right? How many unit cubes you can put there. Okay, if you have an answer, you can post it here. So the picture is clear, right? You use a piece of paper and you cut 4 identical squares. Right. Oh. Okay, so Rebecca has answered. Great. Okay, so let's. So all I have to do is figure it out the length, and this is 11 minus 4, right? It's going to be 7. And the other side, 8 minus 4 is just only 4. And the height is 2 because you cut the 4 by 2 by 2 square. So what you get is the volume is just the product of those numbers, 7 times 4 times 2, right? So the answer is 20, no, yeah, 56, okay. 56. Right. Right. Yeah, what's the 8? Okay, 8 is original width of the paper, okay, a paperboard. But after you cut 4 squares, and then it becomes 4. 8 minus 2 minus 2, it's 4. Alice got 36. And actually the volume is 7 times 4 times 2. If you draw the picture correctly, right, then you get. All right. So our next problem, okay, I have a 2 by 2 by 2 cube consists of 8 unit cubes, right? A 2 by 2 by 2 cube consists of 8 unit cubes, right? Okay, so let's draw the picture. All right. So what I'm going to do is I'm going to paint this cube over the surface, completely paint. Okay, all the faces are painted. Okay. Then you cut them. Okay, so you get lots of cubes, unit cubes. Okay, so for example, that cube become here, right? And you find out not all the sides are painted. There's 2 sides of this unit cube, 2 faces. I think 3 faces are not painted. Okay. Okay. So you have lots of them, right? Okay. So like this one, let's put it here, and all the faces you can see are painted. Okay. So you have so many. Total, you have 8 cubes. My question is, what is total area of the unpainted faces of the 8 unit cubes. Okay. Yeah, any of these unit cubes, okay, has at least a couple of the faces are not painted. Can you collect them and find the total area? Yeah, what is the best way to solve this problem? I see Ethan and some of you already give me the answer. Okay. So why people get the answer using just multiplication, right? So because you find out, yeah, this is one way to do. You find out each of the cube has 3 faces and painted. And then you can use the product, right? So the answer is 3 times 8. So it's 24. However, if I change the problem a little bit, you probably cannot do like this, okay? Instead of 2 by 2, I'm going to do 3 by 3 by 3, right? Okay. So in this case, you painted it. And then you cut them into many cubes. Unit cubes. So some cubes, all the faces are not painted in this case. Some cubes, one face has a painted, right? So it's getting more and more complicated, right? So you don't have a, they're all the 1 unit cubes are not the same. Okay, for example, the one on the top, I can see that, and the one on this side, just only one side face is paint. Okay, look at this picture. Like for example, this one, right? The one here, it's like that. Okay, so some of cubes are not painted, or no faces are painted. My question is, what is the total surface area of all the unpainted faces? Okay, of the, how many here? 3 times 3 of the 27 unit cubes. So you cannot say 27 times 3. Right? So it's not easy to do, right? So the idea is that, okay, we use a subtraction method to solve this problem. So first of all, you look at all this 27 unit cubes. right? And all the unit cubits, right? So you have 27, 3 times 3 times 3, right? 27 unit cubits. But each unit cubit, how many faces there? 6 faces. So 6 times 1 square. So that is a total surface area of all the unit cubits, right? Right, because you have 27 unit cubits. Each unit cubit has a 6, uh, yeah, 6 square units of area. Okay. Now, how can I figure out the total area of the n-painted faces? Well, you just need to minus the total area of the painted faces. Okay. The total area of the painted faces. And it's much easier to calculate painted faces because those painted faces, they are formed, if you put them back, they form the larger unit cube. Okay, so that's why this part is going to be the surface area of the larger cube, right? Do you agree? Surface area of larger cube, because if you put all these painted faces together, you form the surface of the larger cube, right? Right. So therefore, it's going to be 27 times 6 minus the larger cube, right? Larger cube is going to be, you have each face is 3 times 3, right? Right. That's surface area, and the times 6 because 6 faces there. Okay. So let's calculate this. Right. Let's calculate this. Okay. 27. Yeah. So a simple computation gives you the answer, right? 27 times 6 minus 9 times 6, 108. 108 is correct. So 108. Okay. So the idea is use a different, instead of finding the total surface area on unpainted faces, you find the total surface area painted face. But those painted faces of these 27 units cubits, if you put them back, they form the surface of the whole of the larger cube. So you can use the larger cube to find the area. Right. All right. Now, before we solve the other problems, let's talk about the equation. Remember, right? X squared equals a. Then a is positive. Then you define the square root a, right? X is going to be square root a, and also there's a negative solution. So plus minus. Okay, this is how do we define the square root? Okay, the square root a is the number whose square is going to be a. Right. Right. Now, you can also consider this equation. And here I don't have any restriction on a. A could be negative, could be positive. So how do we denote the solution? There's only one real number. Right. There's only one number satisfying this equation. Okay, you guys have to stop it. Don't chat in the chat window, okay? So the solution will be denoted by the third, it's called as the third root of a. Okay, so we also assume you can assume A is num. Okay. Okay, so what is the third root of 8? The third root of 8 is 2 because 2 cubed is going to be 8. Okay, right? We have to use put a 3 there. Sometimes we have to denote the solution by the third root of some numbers. Okay. All right, now we are going to look at okay, here's a question. Okay, a cube has same volume, okay, as prism in dimensions, okay, 1 by 2 by 4. Okay, my question is, what is the difference of their the surface area? So any difference? Okay. So here's a cube, okay? I don't know the exact size of the cube, okay? And this is a rectangular box, okay? So that's gonna be 1, 2, okay, so here's, yeah, let's look at that. So 1, 2, 4, it's actually 1 times 2 times 4, okay? So those two, a cube is special, okay? Cube is special, right? Cube is a special prism. Okay, let's calculate the surface area, do the comparison. They have the same volume. Okay, so they have the same volume. So first of all, let's figure out what is A. Okay, I know the volume is going to be A cubed, right, on the left-hand side. And this is volume is 1 times 2 times 4, which is 8. So A cubed equals A, right? Okay, so A is going to be 2. Okay, A is going to be 2. So now let's find the surface area of both sides. The surface area of cube is going to be, how do you find that? Well, you have 6 identical faces. So 6 times each face's area is 2 by 2. Okay, so it's going to be 20, 24, right? Now, how about the surface area of the prism? The surface of prism is a little bit complicated. Okay, so you have 4 times 1 plus 4 times 2, right? Plus 1 times 2, and those are 3 faces, and you have 6 faces, so multiply by 2. Okay, so let's try to compute. Right, it's 4 plus 8 plus 2. 14, so it's 28. So 28 is larger than 24. Right, so the difference is going to be 4. So the area of the prism minus area of the cube is going to be 28 minus 24 is 4. So what's the fixed volume? I think the cube has the least possible surface area. Do you agree? What's a fixed volume? Okay. Among all the regular prism, the cube has the least possible surface area, right? So any other prism It takes, if you want to have the same volume, it will have more surface area. It's not easy to prove in general, but from this example, you can see that, right? So if you have a limited material, you want to build a prism to hold like a 3 gallons of water. What kind of a box you're going to make to minimize the surface area or minimize the cost of the material? A unit box, okay? So this is a place where mathematics is used, okay? This is where, yeah, unit box. If you build any other boxes, it have more surface area, even if you have the same volume, okay? So anyway, let's take a look at the cube. Cube is so special, right? Cube, A and A and A. The volume is going to be A cubed, A times A times A, okay? And the surface area is A squared times 6, right? A squared times 6, yeah, okay? Now, so here's a question. If a cube has a surface area, has an area of 54 square centimeters, what is the volume? Can you figure it out? Because the shape of the cube is uniquely determined, right? Right. So how do you do that? You draw the cube, and you write down what you're given. The surface area is an area of 54, so 6a squared equals 54. Okay. Then a squared is going to be 27. No, it's a 9, right? Okay. So the edge length is going to be 3. Then the volume is going to be a cubed. It's a 3 cubed. It's 27. All right. Now we are talking about. We're going to study the space Pythagorean theory. Okay. So this side is A, this side is B, this side is C, and then I have a diagonal D. So how can I figure out the diagonal if I know the 3 sides? All right, so what you do is you draw the line here, and there's a vertical right triangle. Okay, right, it's vertically sitting there. So for this right triangle, and this side is x, right? So what do you get? D squared equals x squared plus c squared. Okay, right? That's the Pythagorean theory. Then you look at the triangle at the bottom, and x squared is going to be a squared plus b squared. It's also from Pythagorean theory, right? You have 2 triangles to look at. One is the triangle, right? There's 2 triangles. And you apply the Pythagorean theory. So this x squared is replaced by a squared plus b squared. So d squared is a squared plus b squared plus c squared. Okay? All right, now using this formula, okay, let's find out what is the space diagonal. Okay, so here's a 4, here's a 1, here's 2. Okay, find the D. Okay. All right, so D, yeah, that's right, use a Pythagorean theory twice. So you get the Pythagorean theory for the space, not triangle. All right, so D square is going to be 1 square plus 2 square plus 4 square. Okay. So add all together, it's 1 plus 4 plus 16. It's 21. So D is going to be square root 21. And the length, it's a diagonal, right? It's diagonal. And it's the length of the diagonal. Okay. If you want to tell how big of square root 21, you draw a rectangular box. The length of diagonal is going to be square root 21. All right. All right. Yeah, please don't type the nonsense. Okay, Eric, I give you warning. All right, so here's another question. Let's look at the special case. Yeah, the special case when it's cube. And the length of the diagonal is going to be d squared equals a squared plus a squared plus a squared. So that would be 3a squared, right? Right? So how can I express d? D is going to square root of a squared, 3 times a squared. So I can express it in this form, right? The square root of a squared is just a. So d is going to be square root of 3 times a. Remember the unit square, right? The square of edge length of a. So in this case, d is going to be this d is going to be square root 2a, right? Now, can you imagine a cube in 4-dimensional space or 5-dimensional space? Okay, how does a cube look like in 4-dimensional space, in 5-dimensional space? You can search on internet. Maybe they will show you a picture. Okay, but it's hard to show you a picture on the screen. Okay, it's really not easy to see it. Right, but you have to use your imagination. Okay, then a cube in the n-dimensional space is the length of the diagonal. You can believe that it's just a square n times a. Okay, so I cannot draw the cube in the n-dimensional space or 5-dimensional space, 6-dimensional space, but I can tell you the length of the diagonal of the cube in the 5-dimensional space, which should be equal to square root of 5 times the edge length. Okay. Right, so let's take a look at the following problem. If the length of a diagonal in a cube is 2 square root 3 centimeters long, what is the surface area of this cube? Okay, so that means I have a cube. I know this is a 2 square root 3, although that length uniquely determines the size of the cube because all the sides are equal, right? So you can tell everything about volume and surface area. Right? Right, how do you do that? So first of all, you write down the formula for the d. D is going to be square root 3a, right? And the surface area is going to be 6a squared. So using those two formulas, okay, I already showed you how to get these formulas, right? So you have to derive those formulas by yourself, okay? Then you can understand those formulas. So D is going to be square root of 3. And what is A here? A is going to be 2, right? Yeah, it is 2. So once you get A, then you can get the surface area, right? It's 24 centimeters, square centimeters. So you have to put square it, okay? Right? Okay, if a cube, right? If a cube is divided into okay 27 cubes the same dimension. Right. So that means basically you have a cube here. You just divided them into 27 smaller, identical smaller cubes. Right. My question is, what is the ratio of surface area? I just say area, okay? Total surface area. Come on, surface area is a larger cube compared to total surface area of all the smaller cubes. Right, and here will be the surface area of all 27 small cubes. Okay. And I want to see if this is the same ratio or not. And then you were surprised more cubes you have been cut. Okay, and then the surface area of all the smaller cubes is getting larger and larger and larger. Okay? But the surface area of the larger cube is fixed. So this side is A, this side is A, this side A. A smaller cube, right? It's going to be A over 3, A over 3, A over 3, right? All right, so let's look at the ratio. So it's going to be 1/2, Eric? Any other? Some of you already get an answer. Yeah, so let's do it. Surface area 6a squared, right? That's surface area of a larger cube. Larger cube. And then you have 27 smaller cubes, so it's 27. And each smaller cube, the surface area is 6 times the edge length squared. So, okay, let's simplify, right? This is a surface area of one small cube, right? Then you simplify, okay? And this is a squared and a 9, right? So this a squared is gone, 6 is gone, 27 divided by 9 is going to be 3. So it's 1/3. So the surface area of the total surface area of the system, those smaller cubes, it's 3 times the surface area of the larger cube. So more smaller cubes getting smaller and smaller, the surface area is getting larger and larger. Total surface area. Okay, let's find out the total surface area of this. Okay, I'm going to put this is a cube 4 by 4 by 4. Okay, and here I'm going to how can I draw it? It's harder to draw it. Okay. So that will be 2, 2, and 2. These 2 cubes are glued together. Okay, my question is, what is total surface area? Now, the attached part, it cannot be counted, okay? It's glue them together. Mm-hmm. So Rebecca, you have 80? Yeah, we glue them together, right? Now, so first of all, you assume they're separate. Okay, how do you calculate them, right? Suppose you assume that they're separate, and then you calculate the surface area of a bounce. Add them together, right? Okay, so surface area is going to be the one at the bottom, right? So it's 6 times 4 squared. And then plus 6 times 2 squared, right? Then you have to subtract something. I found out that that piece, okay, should be deleted. Because that face, surface, right, total, right, it's going to be 2 times 2. So that face from the smaller cube should be deleted. So it's minus 2 times 2. But that area also be, covered up. So that should be also deleted from the larger one, right? So you will get okay, how do you calculate, right? So 6 times 16 plus 4, right? Let's make it easier, you see? Minus 8. Okay, so it's going to be 120 minus 8. And the 100 minus 8 is 112. I think Erica's answer is correct. Okay, now you have to subtract the 2 faces, not only one, because this part is glued together. Right, this part is glued together. You see, you have to subtract it from the smaller cube, also subtract it from the larger cube. Okay, right? Do you understand? Yes. So just be careful, when you do the calculation, you have to, don't double count them. Now the volume is not being changed, right? When we touch two cubes together, the volume is not changing. Okay. Okay, let's make a cube with open top. Okay, cube with an open top. Okay. And then I have also have a this is the 4, 2. At the box. Okay. Okay, this one also a prism with open top. Okay. Assume that they have the same volume. So my question is, which surface area is large? And why? How much? By how much? Okay. So because they have the same volume, so a cube is going to be 4 times 2 times 1, which is 8. So a is going to be 2, right? So let's calculate the surface area. Be careful about surface area. This time we have to subtract one face. So the surface area of a cube is going to be, I can use subtraction. So 6 times a squared minus, actually 5 faces here, minus a squared, so 5 a squared. 5 times 2 squared, it's going to be 20, right? How about the area of the prism? Well, let's look at the formula, right? Look at the picture. Which ones are not included? The 1 was 4 and the 2, right? So we can use a subtraction to get that. Well, 4 by 2 is not. So 2 by, yeah, you can say 4 times 2. Okay, 4 times 2. You only count the 1. And the 4 times 1, I think you have to count the 2. Yeah. So times 2. And then 2 times 1 have to times 2. Okay. So it's going to be 8, 8, and 4. So what do you get? You get the same. Right? So this is kind of against our experience, right? If we have a one cube, all the faces count. Another prism, all the faces count. If they have the same volume, then the cube has a less surface area. But now, because one top is open, right? So not included. Then you find out that they still have the same surface area. So it doesn't matter which one you're going to make. Depends on how convenient you are, right? You don't, if you make it as a cube, it does not save you the surface area. You know, that is cost for the material, right? So you can either make this this contains a rectangular box, right? Or you can make a cube. Okay. Anyway, the top is not included, so it's not a big deal. If the mathematics tells you there's the same surface area, okay? So you see, that's the power of mathematics. Mathematics can predict exactly, okay, how much material you're going to use, and this shows you both use the same amount of material if you make the box. Okay, so let's stop here.